Okay, here we go. Our objective for today, I can simplify exponential expressions using the division properties of exponents. Let's read together. 1, 2, 3. I can simplify exponential expressions using the division properties of exponents. Read it again. 1, 2, 3. So yesterday we covered multiplication. Today we're working on division. Okay? So we don't need a Frayer model because we already saw that yesterday. We know the concept. We don't need steps either because the steps are pretty much the same. So I want to get us started right away with our properties for today, for division. So once again, we know what exponential expressions are. Is that correct? Yes, Mr. Q. All right, good. We know the steps also. Identify the exponential expressions, but we're going to look at quotient of powers, power of quotients, and the same thing for the rest, compute and simplify. So on your paper, copy this, please. Quotient of powers property. Quotient of powers property. Whoop. Example Q. Copy this down. 3 to the 6th over 3 to the 4th. Underneath that, x to the 10th over x to the 7th. Underneath that, x to the 5th over y to the 4th. Okay, and let me go over the property before we move on. So that, like that, you can come up with your definition. We need a definition. So, pens down, eyes up here. So check this out. Look up, please. Here it goes. Okay? Talk it over with your neighbors. What happened here and what happened here. Go. All right. Did everybody copy that? Okay. Copy that, please. And as you're finishing copying that, at the bottom, I want you to draw an asterisk and a heart. Oh. Like that we can write our definition. Okay? So let's see. You talked about it. You have a rule already in your brain, right? And you know why this last one, why it remained like that. Okay? So let's start our definition. Yesterday, we started our definition for multiplication by saying when multiplying exponential expressions. So today, how would we start our definition for division? When dividing exponential expressions what? What do I write next? When dividing exponential expressions of the same base comma then subtract the exponents. Period. 10Q. Bam. Anissa in the house. Does that make sense? Yeah, right? Let's read it again. Let's see. It says, when dividing exponential expressions of the same base, then subtract the exponents. Well, let's see. Were these the same base? Yes. 6 minus 4, that's 2. Were these the same base? Yes. X, 10 minus 7, that's 3. Were these the same base? No, that's why they remain the same. Okay? Now check this out. Let me show you why it works. Why does it work according to the rule? Because I just gave you the rule, right? So pens down, eyes up here. Look. Look up, please. Pens down. Writing utensils down. Here it goes. 3 to the 6 is the same as 3 times 3 times 3 times 3 times 3 times 3. Do you agree with that? Yeah. 3 to the 4th is the same as 3 times 3 times 3 times 3. You agree with that? All right, so check this out. What is 3 divided by 3? 1. 3 divided by 3? 3 divided by 3? 3 divided by 3? Well, guess what? This became a giant 1. So therefore, what do we have left? 1 times 1 times 1 times 3 times 3. What is 3 times 3? 3 to the 2nd. See how that worked? These, whenever we multiply different numbers, these are called factors. That's why this is called factored form. So whenever you're working on these and you use this rule and you still have doubts, maybe you're thinking, it might not be right, then factor out. When in doubt, factor out. When in doubt, factor out. Copy that, please. Okay? So do you think it will work if we do it with X's? Yes, let's see. 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 7 down here. 1, 2, 3, 4, 5, 6, 7. Do you see the giant 1? There it is. And what do we have left? X to the 3rd. Why? Because this plus this plus this is that. Does that make sense? Yeah. When in doubt, factor out. We got it? Let's practice. Let's see how we do. Copy this, please. Example 1A and 1B. We got 2 to the 9th over 2 to the 7th. And for B is y over y to the 4th. Copy those and see if you can simplify those. Go. Okay, let's see what we got. For 1A, what'd you get for 1A, Brian? 2 to the 2nd power. Is he done? No. What is 2 to the 2nd power? 2 times 2, which is 4. Hands if you got 4. Okay. B, y divided by y to the 3rd. What did you get for this one? Go ahead. Y to the negative 3. Hands if you got that. That is correct. This is a 1, so therefore 1 minus 4 is negative 3. Okay? Remember, when we're dividing, we subtract exponents. So with that said, any questions on the quotient of powers? We're good, right? However, who noticed that in the home play and yesterday in the warm-up, we ended up with a lot of negative exponents? You guys notice that? Okay, for today, we're no longer going to need negative exponents. We're going to, whenever you end up with a negative exponent, you're going to have to change it. Let me show you. Pens down, eyes up here. Here we go. Whenever you end up with something like this, for example, 3 to the negative 2, from now on, this becomes 1 over 3 to the second, which becomes 1 over 9. Some of you are saying, but why, Mr. Q? Let me show you. If I had 3 to the fourth over 3 to the sixth, what happens to the exponents? Subtract, so this is 4 minus 6, that's what? Negative 2. We end up with this, right? But how does this turn to this? Let me show you. Look up, please, or you're going to miss it. Three times 3 times 3 times 3. 3 times 3 times 3 times 3 times 3 times 3. 3 over 3, 1. 3 over 3, 1. 1 and 1. Therefore, what is 1 times 1 times 1 times 1? What is 1 times 1 times 1 times 1 times 3 times 3? 3 to the second. And that's what we get here, which becomes that. Everybody with me? So what does that mean? That from now on, whenever you have a negative exponent, this is why it works. But the shortcut is just changing this to this. Are we there? Now, how is that possible? Because I just showed you like this, right? Or if you think about it like this, watch. Can't we write this over 1? What is the reciprocal? 1 over 3, but we change that to a positive. Are we there? So copy this down. Example, mega cube. Copy 7 to the negative 2. How would we write that without a negative exponent? Talk it over with your neighbor, see what they got. Let's see. What do I get from here? Daphne, what's the next step from here? So it's 1 over 7 squared, and what does this become? 1 over 49. Hands if you got that. Okay, let's do another one. Example, super duper Q. 2 to the negative 5. Go. See what you get for that. Copy that and go. Okay, what'd you get for this one, please, Amelia? One over 32. Hands if you got that. That is correct. We got this, right? Yeah. Here goes a challenge one. Ready? Power Ranger Cube. Here we go. 2 to the negative 4 over 3 to the negative third. Go and think about it. It's a little curveball, but see if you catch the little curveball. Go. Copy that and simplify. Okay. Let's see. And make some room here. What do we know about this one? This one goes where? On the bottom, and it becomes a positive, right? But we have a dilemma here. In the bottom, we have one that already has a negative exponent. So what do you think I should do with this one in order to change it to a positive exponent? Send it to the other side. So this becomes 3 to the positive 3. If this one went to the denominator and it changed to a positive, if this one's a negative, to change it to a positive, it goes where? To the numerator. You guys see that? Therefore, this is 3 times 3 times 3, which is 27. This one is 2 times 2 times 2 times 2, which is 16. And let's simplify. How many times does 16 fit in here? 1, and we're left with 11 sixteenths. Okay? Let's try another one. See how you do with this one by yourself. Shazam Q. Copy this one. 4 to the negative squared over 5 to the negative squared. Go. See what you do with that. Copy and simplify. What did we write? 4 to the second in the denominator, 5 to the second in the numerator. So this is 25 over 16, which becomes 1 and 9 16. Hands if you got that. Okay. All right. Let's move on. Example, let's see, Michael Jordan Q. Here we go. A to the third, B to the seventh, C over A to the fifth, B to the second, C to the eighth. Let's do this one together. Do this one together. Here he goes. Are these the same base? Yes, so we write A. What happens to the exponents? Subtract, so this becomes what? Negative 2. All right, let's go to the next one. This is the same base. Subtract the exponent, so this is to the fifth. What is the exponent on this one? 1. So these are the same base. And this is negative 7. Do we know what to do from there? Yes. We can't have these negative exponents. Where do these go? In the denominator. So this is A to the second, C to the seventh. What stays in the numerator? B to the fifth. Let's do another one. You do this one by yourself. Example, let's see. Yeah, Dragon Ball Z Q. Here we go. A to the fourth, B to the 10th, C to the second, D to the 10th, over A, B to the 15th, C to the third, D to the 12th. Go. Focus, please. Copy and simplify. Okay, since Brian was the first one to speak, so he's probably done. Let's see. What'd you get for this one, Brian? Here we go. What is it? B to the 5th. Negative 5. Okay, let me go over this one. We got 2 more. Give me a second. Here it goes. This one, same base. That's A. Subtract. That's to the 3rd. Same base. Subtract. That's negative 5. Same base. Subtract. That's negative 1. D. Subtract. That's negative 2. We cannot have these negatives. Therefore, this one is A to the 3rd over B to the 5th, C to the 1st, D to the 2nd. Hands if you got that. Okay, we'll stop right there. Home plate is on page 467. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.